Hello everyone. In today's video, we're gonna talk about a few numerical optimization methods. So machine learning, abstractions, means in general, when you apply the machine learning methods to some real problem, what's the problem you should consider? Okay, and a lot of cases, machine learning algorithm depends on the numerical optimizations. Optimizations. So usually, if you want to write a large computer program, you need to break it down to subroutines and modules. And many of you may have some experiences in computer science, right? So you need to have disciplines to impose strong abstraction between the different modules, and your program will become so complex. It's hard to manage it. So let's talk about the basic big graph about machine learning. So the first step usually we consider in data science, apply machine learning in data science is application and the data. If you took the class like principal data science and data science machine learnings, that's usually the first step in data science cycle. Data science problem always start is question oriented, problem oriented problems, and how to get the well prepared data is a big part of the data science. And as this step, you need to consider where your data come from and what's your data looks like. For example, if you consider if your data has label or not or no label. Okay, for example, if you have some data like if you work in the bank and you want to classify the applicants for credit card. So for that problem, your data has labels, right? So if you have label, you can consider to apply the method we just introduced in the last few lectures, classification methods or support vector machines. So if yes, you can think about to apply. Your label could be categorical. So you can think about the classification machines. Classification, okay. If your output variable is not the categories, or it could be like a quantitative, like a height, income, house price. So those quantitative variables. So you can think about the regression. And in the future, in the next few lectures, we're gonna talk more about the regression. If you this is called supervised learning. If your data does not have the labels, okay, you can still apply some machine learning algorithms like clustering. So by comparing the similarity among the observations in your data set. Similarities. So you can consider the clustering. Or you have some positioning problem. So PO positioning. If you have the large dimension of the input features, you can also consider the dimension reduction method, like principal data analysis, principal component analysis, or some dimension reduction. Okay, so at the first step, applying machine learning, you should think about check what's your data and what your problem is. And then we have a few big categories of the machine learning algorithms. And then you can think which type of the machine learning you can consider. Okay. Second step is about the model. Okay. For example, if you have classification methods, we can have the support vector machine we just covered, and if you have the with like a linear decision boundary decision you can also have the, if you think your data set is not linearly separable, you can also consider the nonlinear separable decision boundary with polynomial transformation of features. Polynomial. Later on, we're also gonna introduce some regression type can also be used for classification, like logistic regression. And a neural network. Neural network. We later on we also can, even for the classification, we also have other different models. For example, in this semester we're also gonna cover decision trees. This is also one of my research interested in. So there is even Bayesian methods to construct the decision trees. Even the Bayesian trees. Okay. You could also consider the nearest neighborhood methods. So those are all different types of the machine learning algorithms you can apply to the same classification problem. Okay. And once you have the model, once you can able to construct some model, okay, I think I need more space here. So step 3 is the once you have some model set up, remember the support vector machine, we convert our problem to be the optimization methods, like a perception algorithms. We use the gradient descent algorithm or stochastic gradient descent algorithm. And later on for the hard and soft support vector machine, soft and hard margin soft vector machine, we considered the minimizations with the constraints. So those are the algorithms we need to determine the parameter values inside the model. So we convert, once we have the model, we have the optimization methods. To solve parameters. In machine learning models. Okay. For example, we have the gradient descent algorithm. And a stochastic gradient descent algorithm, and the linear programming, right? Linear programming methods and quadratic programming. So those are all optimization methods to solve the parameters in the machine learning models. We already see this one. Later on, we're also gonna see there is also maximum likelihood. Methods. Also even the Bayesian methods to make the inference. Okay, so that's the optimization problem. And then last step is you have the optimization algorithms. Maybe it's better to say this is optimization problem. Okay, and then you have the optimization algorithm. Okay. In this course, we're gonna focus on for the more data science application on how to get data. We have the principal data science and the data science computing course. We talk more about this area. And in this section, in this course, we mainly talk about all kinds of the machine learning models and what's the optimization problem we're gonna face into, and teach you how to apply the optimization algorithm we learn ready to use in some packages to solve the optimization problems here. So we're gonna focus on this tool here. As a data scientist, you might be given an application, and your challenge is to turn it into some to apply some models, machine learning models, and to apply some optimization algorithm to solve that problems. We will talk about optimization algorithm in this video, but usually the data analysis use the optimization codes. It's built in some popular like sklearn modules, and but we just give you some simple instruction how to use them. So we won't give too much details about derivation of the optimization algorithms. So for the second part, the model part, The model has a huge effect on the success of your machine learning algorithms. Sometimes you get a big improvement by tailoring the models or its features to fit the structure of your specific data. The model has a big effect on whether you overfit or underfit. Do you remember last few lectures? If you apply the soft or hard uh, decision boundary, you need to solve the, you have some hyperparameters. You need, when you create the model, you have the like a cost C, right, to control the scale, the slack variables, and also you have some transformation of the features, do you remember the phi function, phi space? Those are the hyperparameters you need to consider whether your model is overfit or underfit. Okay, and if you want a model that you can interpret, you can do the inference. For example, you can apply the simpler models like linear decision boundaries or simple linear regressions. You can have the meaningful interpretations. But if you pick a model which is very hard to, very complicated model like decision trees or the neural networks, it's hard to interpret. And your model could work very well, but it's hard to interpret. And also the optimization could be hard too. It's important that you understand when you change something, when you apply the machine learning algorithms, think about where you are at this machine learning cycle. Okay. So next video I'm gonna give a little bit more details about optimization problems. So in this lecture we're gonna focus a little bit on optimization methods. So far we talk about several methods, right? Problems: gradient descent, linear programming, quadratic programming. So in this lecture we're gonna give a little bit more details.